Hello, once again, AME students, and here we are in the second part of the examples for Unit 2.3. This time we are going to actually use an LU factorization to solve a system of equations or to solve the matrix equation when we're given a specific solution vector. So here you'll see from last time we did the LU factorization of a matrix A, and this was the L and the U that we found from the first video. And now this time we're given a B vector as well. We're going to use the LU factorization to get us a solution vector X for AX equals B. Now the means by which we can use LU will make this into a two-step process, but it's going to be a process that is in each step quicker to do. And if you're going to be repeatedly finding solutions to system of equations with the same A matrix but different B's, this can be quicker than the RREF method that we've been using up until now. The idea here is going to be that if we start off with AX equals B, and we have our LU factorization, well, then we can just replace A with LU. X stays X, B stays B. Now, this is where the technique comes in. We're going to do a substitution here for UX. And we're also going to now say that UX, when I multiply the X vector times the matrix U, that would give us some Y vector. With this substitution, we can now rewrite AX equals B into LY equals B. And now I can use the B that I have and the L that I've had to solve for U, or not to solve for U, but to solve for Y. And then when I have the Y, I can use the U matrix that I came up with and that new Y vector then to solve for X. So let's get into the process. Essentially, we are taking a very complicated matrix that might be hard to solve using Gauss-Jordan elimination, and then turning it into two Gauss-Jordan elimination steps, each of which is much easier to solve. So we're going to start off with our L and with our B and do row reduction on them to get us to some new Y vector. So our L is all of this. We'll rewrite this over. And then we're going to augment that with our original B vector that the problem gives us. So we'll augment this with -9, 5, 7, and 11. Now, the nice thing about how L is set up is that the diagonals are all pivots already. They're all 1, and this essentially is just going to become a matter of adding higher values in the augmented matrix to the values below. So the process is essentially going to be one of adding multiples all along, and really all that's going to change here is this final column. Every step other than that is just going to zero something out on the matrix side. So for our first step here, all right, we're going to take the top row, 1 is equal to -9, and just add that -9 to the values below it, allowing us to cancel out everything in the first column. All right, so 1, 0, 0, 0, and -9. For the second row, we're going to add the first row to the second row, which will give us -4 here. It zeroes out the first value in that row. It's all zeros for the rest of it, so nothing's going to change past that. We're going to subtract 2 of them. from the second row. So this becomes 0, -5, 1, 0. Let's see, 7 minus 2 times -9. That's going to be 7 plus 18 will give us 25. We'll add 3 times -9 to 11, which will give us -16 in this case. 0 at that 3, and the 8 and the 3 and the 1 stick around. All right. The way that L is set up makes this into very simple method of doing the RREF, and that we are just adding multiples of whatever's in the solution vector to get to the next step. All right, so after this, we're going to go column 2. Everything up here is row 1 is just fine. Row 2 has been solved, but now we're going to multiply row 2 by multiples and add those to the next 2 rows. So we're going to add 5 times row 2 to row 3. That will 0 out the -5 and reduce the 25 down to a 5. And then we're going to subtract away 8 from row 4. So we'll get 0, 0, 3, 1, and we should get 16 here. So that's going to be 32 minus 16. And then we'll finish up one last step here. We're going to subtract away, let's see, 3 of row 3 from row 4, and we will end up a final solution here for our first step. We will get identity here on the left side, and on the right side, we're going to get our y vector. That's what comes out here. That will be 9, -9, -4, 5, and 1. Okay, that's what comes out here. This is the y solution to that equation. Okay. Or more exactly, it's that value now. What we want to be finding as our final solution is this x. That x is the same as this x. But what we've now found is a new y that's going to allow us to solve for this. All right, so let us set up this second augmented matrix using now our U matrix. And we're going to augment the U matrix with this new y that we just found. All right, so setting that up, it will get augmented with -9, -4, 5, and 1. And from this will now be a more involved process, but it's still going to be much easier to do because now we are already in REF form. We're now going to need to go to RREF form. So recall that this is going to be generally what we're going to want to do is go from right to left, from bottom to top on our pivots, make our pivots into ones, and then use that to clear out everything in the column above. So in this case, our bottom row is going to turn into 1, -1 now, to clear out everything in the column above it. Right, so columns 1, 2, and 3 will not change at all in this process. Just like in RREF, they would not change because of these zeros that are present here in the bottom row. What will change is that we'll get zeros all the way in this column, and our solution vector is going to change. So first things first, we got to subtract 1 of R4 from R3. That will zero that out and bump this up to a 6. And we're going to subtract 2 away from R2. We'll zero that out and bump that down to a negative 6. And we're going to repeat that step again, subtracting 2 away. I'm sorry, this negative 6 should become not a should not be a negative 6. It should in fact be a negative 2 because we are adding instead 2 to the negative 4. So that's going to become negative 2. And we're going to add 2 to the negative 9. That will become negative 7. Next step is then we're going to move on to row 3, column 3. We are going to keep row 4 as is. That has been solved. We're going to multiply row 3 by negative 1 to change our pivot to a positive 1. Everything that is in row 1 and row 2 will not change. Same thing with column 4 because that's been zeroed out. But we're now going to use this 1 negative 6 to clear out everything above it. So first thing is we're going to have to add 1 of row 3 to row 2 to clear that out, which will make this a negative 8. And we're going to have to add 2 of them to row 1 to clear that out. That will become a negative 19. All right, 2 more rows to do. Moving on to row 3 or row 2. Column 1 stays the same. Column 2, we're going to multiply everything by negative 1/2 to reduce down that negative 2 to a 1. Means our negative 8 will become a positive 4. Everything else here stays the same. Columns 3 and 4 are nice and locked in. And then we have to finish off by adding 7 times row 2 to the first row. That will give us a positive 9 at the top. Zero this out. And then our final step will be to divide everything in the first row by 3. And that will ultimately end up with identity here on the left side. And our final x